Here in this video, we're going to look at topic 90, example 2, use properties of exponents to rewrite radicals. So there's two questions. How can you extend the properties of exponents to derive the properties of radicals? That'll be for part A, and then part B, how can you rewrite each using the properties of exponents? So in part A, this is a lot more theory and practice and showing you a method that you can then apply in more, I'll say, realistic examples. You wouldn't necessarily see a problem like A. But what you're allowed to do is, if you have the nth root of AB, we can rewrite this as a rational exponent. So we can change that to AB raised to the 1 over n power. Remember that index, this n value, would become your denominator, and then the exponent inside, which we can't see, but we know is a 1, would be your numerator. We can then use power of product properties, and that tells us that this 1 over n can be distributed to each of these terms. So we get a to the 1 over n, b to the 1 over n. And then we could rewrite these, go back from rational exponents back to radicals like we started, and you would have the nth root of a times the nth root of b. All we're really looking to show here is that if you have the nth root of a term, you can break up the insides into two separate radicals. All right, that's the important thing. So if you had, say, the cube root of x times y, you can rewrite that as the cube root of x times the cube root of y. All right, you're allowed to do that. That's what we're looking to show in part A. In a similar manner, if you have the nth root of a fraction, so let's say like the nth root of a over b, you can rewrite this as the nth root of a over the nth root of b, okay, which will become pretty useful later in this section. Right. So again, part A is really just in terms of showing us something that we're going to be able to use and apply in future problems. So part B, we have the cube root. I'm going to rewrite this, it's a little blurry, of 16 to the x to the 5th power. So what we want to do here is we want to try to simplify this as best as possible. And we're going to try and take some of the terms outside the radical and some of them may be left inside. In the past, maybe you had like the cube root of, let's say, 27, which we could just say was 3. All right, that was a pretty easy one. But here, 16 is not a perfect cube. And we also in the past had something like the cube root of x to the 6th, and we could do 6 divided by 3, and we would get x squared. Well, 5 obviously is not divisible by 3, so we're going to need to work some math magic here. All right. So cube root of 16, x to the 5th power. My perfect cubes are 1, 8, 27, 64, right? So this is cube root of 1 would just be 1. This is 2, 3, 4, and you can go on and on, but for now, let's just start with the first couple. So in terms of the 16, what we're going to look to do, and again, if you want to break this up this way, you can. I'm going to show more work than necessary, just so we can really see what's going on. Since 16 is not a perfect cube, we need to look to see if we can take this 16 and break it into any of our perfect cubes. Well, 16 is divisible by 8. So we can break this into the cube root of 8 times the cube root of 2. Right, so this is just being split up. Earlier in the year, we did do this with a lot of square roots, but now we're going to look at cube roots, 4th roots, 5th roots, and the like. Now, the cube root of x to the 5th. 5 is not divisible by 3, but what I'm looking at here is I have 5 x's. I can split these into separate groups. So I can create kind of a barrier here, right? And I can have a group of 3 of them and a group of 2 of them. So that's exactly what I'm going to do. I'm going to make a group of 3 and a group of 2. And the reason for that is this 3 is divisible by my index. Okay, so that's what we're looking to do. So this 5, this x to the 5th is being split up into these two. You'll get the hang of it. It'll take a little bit of practice, but Really, you're just going to look to split these up into a number that is divisible by 3. So the cube root of 8 we know is 2. The cube root of 2, we cannot do anything with that, so that'll stay the same. The cube root of x to the third, 3 divided by 3 is 1, so that's going to be x to the first, or just x. And this piece here, this last piece, the cube root of x squared, we cannot do anything with that because the number on the inside, this exponent, is less than the index. So if the exponent is less than the index, you're going to leave it alone. There's nothing you can do. Right? So from here, I'm going to then take my outside pieces, the 2x, and write those on the outside. And then this cube root of 2 and the cube root of x squared, they are both cube roots. So I'm going to put them back together on the inside. And this would be my simplified expression. It'll take a little bit of getting used to, but you will start to learn using perfect cubes, fourth roots, and so on, and then taking your radicals, your not exponents either, your variables, and splitting them up based on their exponents so that the exponent is divisible by the index. Again, it'll take a little bit of practice, but you should be fine. After a couple of examples, you'll start to see what you're looking for, and then you just start applying those properties and going through them over and over. Practice, 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 but you will be able to understand this. All right, that's it for example 2.